Hello and welcome to my fifth lesson on matrices and transformations, in which case I want us to look at applications of the concept that we have tried to look in the first four lessons. Previously, we looked at all of these objectives on your screen. This time round, I want us to try to see how these ones are actually applied in actual questions. And so, for us, we have a set of questions. We have 5 questions. There is that one there. There's another one. There's another one. Another one and another one. We're going to do this in 2 lessons. In the first lesson, we're going to do the first half with the first 3 questions, and the last one I'll do the last 2 questions, and that'll be the end of my series for matrices and transformations. And therefore, I think we should just begin. We're told the vertices of quadrilateral A, B, C, D are given there, and A prime, B prime, C prime is the image of A, B, C, D under the transformation matrix -1, 0, 0, 1. We're told find the coordinates of A prime, B prime, C prime, D prime. Again, draw A, B, C, D and A prime, B prime, C prime, D prime. The next question there we're told find A double prime, B double prime, C double prime, D double prime, an image of the first image under the transformation represented by the matrix 0, -1, -1, 0. Again, we're told to draw the second image. Find the single matrix that maps the second image onto the original object. So yeah, that way. And then the last part is describe the transformation fully. A very much comprehensive question. And so let's begin. The first thing we're told to look for is the coordinates of the first image. And we begin. In the question we were told that first image is obtained by a transformation represented by the matrix -1, 0, 0, 1. Therefore, the way to obtain the coordinates of the first image is by pre-multiplying the coordinates of the quadrilateral ABCD with the matrix of transformation that we were given. Now, please notice that these are the coordinates of the quadrilateral, and if you pre-multiply, you get this one here, which is A prime, B prime, C prime, D prime, and therefore we have actually answered the coordinates of the first image. There's a simple thing about all of the transformations that we normally use in matrices transformations. They're normally not very complex matrices. Like this one is a -1, 0, 0, 1. A simple way of looking at the answer for multiplying the quadrilateral with the matrix is this. This element here is 0. That means whatever we are multiplying, the only thing that we are going to be getting is we multiply this -1 with these figures to get us the x coordinates. That means this coordinate, this x coordinates will reverse their sign. If it was positive here, it will become negative here, and if it was negative here, it will become positive here. Otherwise, nothing else is included there because the next element we are pre-multiplying with is a 0. Since we're going to have -1 times all of this, but 0 times everything else that is on the y-axis. Therefore, all of them here just reverses the signs. No wonder we have 7, 2, -2, 7. Those are the x values. For the y values, we have 0 and 1. That means this 0 will multiply everything here and it goes away. So we just have this 1 multiplying everything else here, and it remains as it is. Therefore, we're just going to have 2, 1, 8, 7. So majority of the matrices we normally multiply are that easy, and we don't need to struggle a lot doing the multiplication. Following the multiplication rules of matrices, it's easy to see the answer that particular way. This is going to be -1, everything here, and +1, everything here. Positive of every figure there, just as I have said there. And therefore, if you find that helpful, you can use it to operate. Therefore, before us we have the coordinates of A prime, B prime, C prime, D prime. The next part we were told to draw A, B, C, D and A prime, B prime, C prime, D prime, and therefore I have drawn that for you. And here it is. We have A, B, C, D. We have the image A prime, B prime, C prime, D prime, and I think not much else there. Then we are told find the coordinates of the second image, which is a transformation of this particular one under the transformation matrix 0, -1, -1, 0. Now, as I've just said, when I was multiplying in the first case there, we pre-multiply the matrix with the image we got. We pre-multiply the image we got with the matrix that we have, and therefore this is the image we had, and this is the matrix that it's forming with. Now, I've said that it's easy to multiply this. For example, the answer for this one will all of them will be the x's will be the y values we have here, only that the negatives, all of them will be negative, and you can see 2 1 8 7, so we have them, but all of them negative. The y values will all of them be this negative times this one, so only that we are going to have these ones, but all of them their signs reversed, since we are multiplying with a negative 1, and therefore we have negative 7, negative 2, 2, 7, and therefore it's easy to always check your work. The next thing we're told to do there is draw that image. We draw this particular one. We have the coordinates of the second image, and so if we draw that, we're going to have it there, and it's this one here. We have A double prime, B double prime, C double prime, D double prime. I've drawn the three of them so that you can see what's happening. The last part, we're told to find a single matrix that maps the last one, this image here, on to the original that we had. The original we had was this one here. It is in this particular part here. Yeah, so we do that part. We are told to look for a single matrix, and therefore we're going to say let the single matrix be, say, A, B, C, D, and so we pre-multiply with the last image, pre-multiply A, B, C, D with the last image to get the object we had at the beginning, because we are transforming the image to to get the object. Because of that's the question we are told. We are told find the single matrix that maps the last image onto the object, and so that's why we're doing that. Another thing I need to mention is that I've only taken the coordinates of A double prime and B double prime and A and B to help me solve that. I don't need the C's and the D's. Therefore, I'm pre-multiplying the matrix I've said A, B, C, D with a 2 by 2 matrix. Let's ignore the C's and the D's to get a 2 by 2 matrix. Again, ignoring the C's and the D's. All right. And therefore, if you multiply A, B, C, D with the negative 2, 1, negative 7, negative 2, negative 1, negative 7, negative 2, you get this 2 by 2 matrix, and that 2 by 2 matrix equals to minus 7, minus 2, 2, 1, and that's what we have there. Okay. Now again, equating elements that are equally placed on the 2 by 2 matrices, you get negative 2a minus 7b is equals to negative 7. That is this one equals to that one. Again, we say minus a minus 2b is equals to minus 2. That one there. And again, the same thing for the c's and the d's. And therefore, we have those four equations. Two of them solved simultaneously would give us the values of a and b. The other two will give us the values of c and d. And therefore, we have a is 0, b is 1, c is negative 1, and d is 0. And therefore, the matrix A, B, C, D is 0, 1, negative 1, 0. We were told find a single matrix. There it is. Okay. The last part of the question was we described the transformation fully. So, how is A double prime, B double prime, C double prime, D double prime? How is it transformed to A, B, C, D? Let's get to that. Describe the transformation. So I have the two drawings. We have the last image we had and the object. So how was the transformation there? Now we're going to eliminate. First of all, this is not an enlargement. Again, it doesn't look like a translation. Again, it doesn't look like a reflection. It is also not shear. It's not stretch. So it's just a rotation. So B double prime must be rotated somehow to get B. The same thing for S and the same thing for C's and D's. So what would be the center of rotation? To me, it looks like this is the center of rotation is the origin, where we have a line like from B to the origin and B to the center of rotation, that is the origin, and again from the origin to B double prime. It looks like that's a 90-degree term. If you look at the A also, again, this is A double prime, this is 7. Again, please consider that we are moving 2 steps that way and 7 steps. And where is the other A? The other A is also 7 steps and 2. That tells you that this also must be a right angle turn. And therefore, look at this way. There's an angle, a 90-degree turn, that's from B to the center of rotation to B double prime. There's another 90-degree turn from A to the center of rotation, that is the origin, and again to A double prime. The same thing, we also have another one for for the C's, C double prime to the center of rotation, which is origin, and again to C. The same thing for D. Therefore, this is a rotation about the center of, about the origin, that is 0, 0, through a negative 90-degree turn, and therefore that describes the transformation fully. Let's move to another question. We're given triangle ABC, and then we're told that H represents a half turn rotation about the point 02. We're told to draw the triangles ABC and A prime, B prime, C prime, and H. Again, we're given two other transformations. T represents a reflection on the line x is equals to 0. K represents a translation 0, negative 2. Find the coordinates of A double prime, B double prime, C double prime, and of ABC, the original triangle, and TK. Hence, draw the triangles. The second image, find the area of the triangle A double prime, B double prime, C double prime, and therefore let's begin. We're first of all told to the first question is we look for the first image A prime, B prime, C prime under H, and therefore I should say this: the original triangle we're given is this one here. We have 2, 5. We have this point here is what is it? Yeah, 4. B is 4, 3. Yes, B is 4, 3, and then we have C is 2, 3. The question is H represents a half turn about 0, 2. This is the center of rotation. So we are supposed to draw the triangle, and you get the coordinates of that, and therefore I need to say this: if it's a half turn, then it means something like this. We take the point C, for example. C will go straight away through the center of rotation to the other side. Since if you are rotating through a 180-degree turn either this way or the other way, it will be such that the point C, C prime, and the center of rotation will be along a straight line. So what I'm saying is, since we have C, we also have the center of rotation. The point C prime will be continuation of the line C to center of rotation on the other side, and therefore that's one thing to say. The other thing is the distance from C to the center of rotation should be the same as C prime to the center of rotation. That distance should be maintained. I say that we have a 180-degree turn there. It should be measured either this way or the other way, since I should say a half turn, whether positive or negative, they are the same. They're identical. Another thing is the distance from C to the center of rotation is a distance, is a diagonal over 1 by 2. Therefore, the C prime will be also a diagonal of, again, 2 by 1 or 1 by 2 if you like. You can still go the other way there. So this, no doubt, will be the point C prime. So that's the point C prime. We do the same thing for A. We take a line from A to the center of rotation, progress on the other side, ensure that you measure this distance. You can measure using your compass or a ruler or whatever, but I always suggest that it's good to use the squares, since sometimes some of the graph papers are not perfect squares, and therefore if you use the squares that you're given, you'll improve your accuracy and the diagram will look like it should. So you get this distance is a diagonal over 2 by 3. Progress on the other side, you have 2 by 3, and therefore obviously the point A will come here. So we have A prime there. The same thing for B. B to the center of rotation, B prime will be continuation on the other side. The distance is maintained, and therefore we get the point B is that, and therefore the triangle we're looking for is the one that has come up there. Okay, and just in case you want the coordinates, you can always read them from there. The next question is we are told to reflect the original triangle through a successive transformation TK. So the coordinates of the second image, A prime, A double prime, B double prime, C double prime, are TK. Let me say this: since we are doing a successive transformation, we'll first of all need to say this: TK means K is performed, then T, strictly in that order. Now, K was a translation of 0, negative 2. Now, the translation vector is 0, negative 2. Now, we have the triangle ABC, is that on there? Since we are translating through 0, negative 2, it means we'll not move either rightwards or leftwards. We're just going to go downwards with a negative 2 steps along the y-axis. Again, let me say this: the point F, for example, will not move either this side or the other side. It will only go downwards two steps that are negative. No wonder we're going downwards, and therefore I should say that A moves just downwards 2 steps to this point, C will move just downwards this point, and B will move downwards that way, so that we translate the triangle ABC to that particular triangle there. That is K. Then we go to T. T was a reflection on the line x is equal to 0. Therefore, I should say that x is equal to 0 is the y-axis. We are reflecting this triangle on that, and therefore, how do we go about that? The point here, this point will move across such that this line is perpendicular to the middle line, and the middle line is a perpendicular bisector of the line that I have there. Okay. Therefore, what I'm saying is that we should have a right angle turn there. Again, this distance should be the same as on the other side there. So this point will move across that way. This point also again will move across to this point. And the last point, this point here, will move all the way up to this point, such that this distance is same as the other one, and yet that line is perpendicular bisector of the middle line, or the middle line is perpendicular bisector of that particular line. Therefore, the triangle we're looking for is that one there. We are told to look for the coordinates of the second image, and therefore we have A double prime, B double prime, C double prime. You can always have the coordinates if you want. The last part is find the area of the triangle or that second image. Again, I've extracted this triangle here. The steps from the point B double prime to C double prime is 2 steps, since it's from -4 to -2. And the other one is also 2 steps. So the area is just an area of a triangle, which is 2 times 2 over 2, which is 2 square units. With that, we go to the last question in this particular lesson. We're given a triangle ABC. We're told ABC are those coordinates there. We're told the vertices of the triangle is transformed. Sorry, the vertices of the image of this one are the ones given there: A prime, B prime, C prime. Now we're told that A prime, B prime, C prime is a rotation of ABC. We are told draw the triangles ABC and A prime, B prime, C prime, and find the coordinates by construction. Sorry, find by construction the center and angles of rotation, the angle of rotation, since we are told that this image is a rotation of the object. Find the vertices of second image, where that second image is the image of the first one and a reflection of that first image along the line y is equal to x. Draw the third image, which is a reflection of the second one along the line x equals 0. Now find the triangles drawn from that. Find from the triangles drawn, find one pair that is directly congruent or one that is oppositely congruent, and therefore we begin. As we begin, I think I give you time. Always try and understand all the questions that are required in that kind of package there. Anyway, the first question we are told is we draw the triangles ABC and A prime, B prime, C prime, and therefore I've done that for you. We have the ABC, and then we have the image there. Okay. Then we were told find by construction the center and the angle of rotation. We are told that this image is obtained by rotating this other one, the object, and therefore we are told to look for the center and angle of rotation. And so we begin. First of all, we draw a line, say from A prime to A, a straight line, bisect it, draw another line from either B prime to B or C prime to C, bisect it. Where those two bisectors will meet, that happens to be the center of rotation. And so I have the line A prime. I bisect it. Bisect means we have a 90-degree turn, how the two lines meet. We have another line, say B to B prime, and that again is bisected, and they met at the point 3, 2. That is the center of rotation. The angle of rotation. The angle of rotation is, we just take a line, say B prime to the center of rotation and then to the point B, or you can take A prime to the center of rotation to the point A, or C prime to the center of rotation to the point C, and measure the angle. In our case, the angle is a 90-degree turn. Therefore, we would say the angle of rotation is -90. Why? Because we are moving clockwise. And I think that's simple. Let's go to the next part. We're told to look for the coordinates of second image, and the second image we're told that is the first one is reflected on the line y is equals to x, and therefore we go to that. We have this first image reflected on the line y is equals to x, and this is the line y is equals to x. The question is, what are the coordinates of a double prime, b double prime, c double prime? Therefore, I need to say this. To reflect again, we should have lines that are perpendicular to the middle line, like c perpendicular to the middle line that way, a perpendicular to the middle line that way, and b perpendicular to the middle line that way, such that all of these lines are perpendicularly bisected by the middle line. Again, we ensure that this distance is measured on the opposite side. So this point must be c double prime. Again, a double prime, we just cross the diagonal of that particular square to this point, and b crosses 1 square and a half. So we have the half and the 1 square. So it comes to that point. And therefore, the triangle will be that one there. Okay? And what were we told? I think we were told to give the coordinates. So the coordinates are given there, 5, 4, 5, 2, 7, 4. Okay? We're told to draw that, and we have it there. The next thing is we look for the coordinates of a triple prime, b triple prime, and c triple prime. And therefore, we're told it's a reflection on the line x is equals to 0. Again, x equals 0 is a y-axis. So since we are reflecting this second image, we just do what we have done in the previous case. We ensure that we have lines across that way that are perpendicularly bisected by the middle line. So a double prime, we move across, b double prime, we move across. Again, c and a are similar there, so c will be just next there. And follow the processes there, you get the image is that one there, a triple prime, b triple prime, and c triple prime. The last thing we are told to look for congruence, and so we move to that particular part of the question. Which triangles are directly congruent? Are they there? So what I have done there is I have drawn all the triangles on the same Cartesian plane. And so we had that first one there. We have that second, the image, the first image. We also have the third image there, the second image, and the third one on the screen there. So which of these triangles are directly congruent? I should say this, none of these triangles are directly congruent. Why? Direct congruence means one triangle should fit into the other one without being overturned. If you take, say, the original thing we had, the triangle ABC, there is no triangle that you can lift this one and just drop on it and it fits perfectly. Same way, if you take this one here, there is no such a triangle that you can lift a prime, b prime, c prime to fit into it directly without having to turn it. The same thing for the second and the third. Having said that, we say none of them is directly congruent, but for the oppositely congruent, we say all of them are oppositely congruent. All of these triangles are isometric. Every of these triangle equals to the other one, to all the others, only that they require to have some sort of turning. Like you can put this one directly into this other one here by turning it in some way. And therefore, they are all of them directly congruent. That brings me to the end of my first revision portion of matrices and transformations. I'll be posting this particular lesson at the same time with the next one that I'm going to tackle the last two questions. I hope you enjoy.